everyone, my name is Raina Dijut and welcome to my Module 12 Rocket Food Delivery Backend project. In this video, we are going to go over our Rocket Food Delivery, which is a Spring Boot food delivery backend. It is a REST API platform that manages users, restaurants, products, orders, couriers, the whole food delivery workflow. The key thing about this project is the architecture. So we follow a clean 3-layer pattern: controller, service, and repository. Every single endpoint, every domain flows through these layers in the same way. Today I'm going to walk you through an entire address domain to show you exactly how that works. And then I will briefly show you that orders, products, customers, and the rest of them all follow the same pattern. So without further ado, let's get into it. So before we dig into the code, let's talk about the flow of this project. So every API request follows the same path. HTTP request comes in, controller validates the DTO, service applies business logic and maps between DTOs and entities, repository hits the database, and then response flows back up that same path. The reason that we do it this way is because of separation of concerns. So the controller doesn't know about the database, the service doesn't know about HTTP requests, the repository only knows about data access. Each layer has one job. We also use DTOs, which is a data transfer object, as the boundary between the API and the business logic. DTOs are separate from your database entities. The entity lives in the database, the DTO lives in the API contract. This decouples them. All right, so let's look at address. It is a simple domain, which is perfect for understanding the pattern that flows all throughout this project. So layer 1 is the address API controller. It lives inside of this API folder, and let me show you what it does. So this top portion right here that starts with request controller is the constructor injection. It's clean. The controller depends on address service, and that's it. So there's no repositories and there's no database logic here. So if we take a look at this endpoint right here, this is the get API addresses, which gets all addresses that populates an address table on our UI. It's super thin, it's very simple. The get API addresses calls this address service get all. That's all that the controller does. It doesn't fetch data, it doesn't map anything, it just delegates where requests go. Now if we take a look at a post request, we can see right here, and if you take a look at this @valid annotation, this is important. When a client sends JSON to create an address, Spring validates it against API address DTO before the method even runs. If the JSON is missing a required field, like the street address or the postal code, validation fails and the global exception handler catches it, and we'll talk about that a little bit later. The controller receives a validated DTO, passes it to service, gets a response, and wraps it using response builder. The controller is a traffic cop. It's not making any decisions, it's just routing requests and ensuring that requests are valid. Same pattern for the put and the delete: thin, focus, and delegate. Now let's take a look at what the controller receives, which is the API address DTO. So this right here is just plain Java. There's no JPA annotations, no entity, no relationships, just fields with valid constraints and JSON property mappings. The @not blank annotation means when a client sends an address, street address, city, and postal code must not be empty, and Spring validates this automatically using this Jakarta validation. The JSON property annotation tells Jackson how to map JSON keys to Java fields. The client sends street address with an underscore, Java uses camel case, and the DTO handles that translation. Why is this separate from the entity? Because the database schema can change without breaking the API. If tomorrow we add a building number field to the address table or refactor how the store coordinates, the DTO stays the same. The API contract won't break and everything works out just fine. And layer 3 is the service layer. This is where the real work happens. The service has 2 repositories, so it has address repository and restaurant repository, because addresses are used by restaurants, so service needs to know about both. And if we take a look at the DTO-based service method create, we can see right here at the top, there are 3 steps happening right here. So first, it converts the DTO to an entity. The map DTO address method takes the plain DTO and builds an address entity with it. We save the entity to the database via the repository, and then we convert the saved entity back to a DTO and return it. The mapping methods are private helpers, which are denoted by these 2 private classes right here. And the entity has extra fields, so it's got created on and update on that the API doesn't need to expose. The DTO only includes what clients care about. This is security and API stability. Now, if we take a look at a more complex method, which is the delete functionality right here on the screen. So if we see what's happening, the service enforces a business rule here. We can't delete an address if a restaurant is using it. If someone tries, we catch it with this data integrity violation exception from the database and throw a bad request exception. This gets caught by the global exception handler, which returns a consistent error response, and we'll talk more on that later. The service also has a custom business logic method at the bottom. This finds all addresses not currently assigned to a restaurant. It's business logic. It knows the rules of the domain. This lives in service, not in the controller and not in the repository. So now we can take a look at the actual repository. This is data access. This repository extends JPA repository, which gives us free CRUD operations: save, find all, find by ID, and delete by ID, already built in. The interface shows a custom native SQL queries as well. If we need complex database logic, we write it here as SQL queries. The repository is the only layer that knows about database-specific stuff. So when the service calls address repository find by ID or address repository save address, etc., the repository handles it. The service doesn't care if it's JPA or native SQL, it just calls the method. So next we can take a look at the entity, which is our address.java. This right here is JPA. It maps to the addresses table. It has audit fields, so it's got this created on and updated on, automatically managed by Hibernate. The entity is internal, so the API never sees this. The DTO is what goes over the wire. So if we trace one request, the client sends a post request to API addresses with a JSON body street address 123 Main Street, with the city Toronto and the postal code M5V3A8. So first, in the controller layer, the @post mapping annotation receives the request. Spring deserializes JSON to API addresses DTO. @valid validates it. All three fields are not blank, so they must be present. If validation passes, create addresses is called. Then in the service layer, create DTO is called. Map DTO to address DTO converts the data transfer object to an entity. Address repository save address persists to the database. Hibernate inserts the addresses table and generates an ID. The map addresses to DTO saved address converts entity back to DTO and then returns the DTO with this new ID. And then the response is a normalized JSON response with the ID number, the street address, city, and postal code of that initial request. The controller wraps it in a response envelope using Response Builder, sends HTTP 201 created, and sends it back. That's the flow. So there's about 4 layers, clear separation, and all of it is very testable. And here's the key insight to this project. Every single domain in the system follows this exact same pattern. So if we look at the project structure, we can see that product, order status, order, employee, customer, all of them have DTOs, all of them have controllers, all of them have API controllers, and all of them also have repositories, service layers, and then the templates, which is on the UI, which will be in another video. Every endpoint, every domain, the pattern across the board is consistent. Some domains are more complex, like the order domain might have to orchestrate several repositories. It needs to update the order, update its items, check courier availability, but the layers are still there. The controller is still thin, the service still owns business logic, and the repository still owns database access. The consistency in this project is powerful. So once I understand address, I understand the entire code base. And so how do we test this? This project includes a folder called test, and within that folder, we see that there are tests for each domain. So we've got courier, courier status, employee, order. All of these use what is called mock MVC testing, which basically can pretend to be an HTTP request without having to have the server running. So it runs through all of the CRUD functionalities for each domain, and then it will return a result. So the way that we can test all of these at once is by opening the terminal, and then we type mvmw clean test. And the reason I do clean test is just because it'll clear out any old responses, any cache data, and just give us a new test from scratch. So if we hit enter and I open this up, we're going to see the terminal doing a whole bunch of stuff, running through all of those tests that we've wrote. And then right there at the bottom, we can see that we ran 104 tests in total. We have 0 failures, 0 errors, and 0 skipped, and the build was a success. And if we test this in Postman, which we will be doing in another video, all endpoints return consistent JSON responses with a standard success or error structure. If something goes wrong, like if validation fails, resource not found, database error, the global exception handler catches it and returns a standardized response. So we can take a look at that really quickly. Right here in our API exception handler, we can see that there are defined responses for not found, validation error, bad request, and then internal server error. All of these also use this response entity and uses this HTTP status, so it sends a status code with the corresponding response. So to recap, we keep the controller thin. It just validates DTOs and delegates to services. The service owns business logic, DTO mapping, and orchestration. The repository handles data access via JPA or native SQL. DTOs separate the API contract from database entities, keeping both of them flexible. So this pattern, controller, service, repository, scales across every domain. Address, order, product, courier, all of them have the same structure. That's what makes this code base maintainable. So that's all I have for this video. Thank you for watching, and I will see you on the next one.